Okay, good morning. So, all of you submit those quick assignments that are given. Watch that video and you answer it. So, I use it as an objective assignment. Okay, and descriptive assignments you submit to the mail ID of the biology sir. Okay, sir has given a day-wise schedule to write the assignments. No? All of you compulsory you submit it. It is based on that only we can assess you. Based on that only we can assess you and we can send the assessment report to JNTH. Accordingly, maybe you will get credits or promotion. So, according to UGC norms, September 1st is the August 1st is the next second year starts on August 1st. Okay, and for coming first is it is September. But semester exams will be conducted in the month of July, they said. Whether it is conducted for fourth year or all the years, don't know. But and one more option, one more this thing is given where this corona effect is less. Almost corona is uh, zero corona regions, states. In that states, they can conduct the exams. This is the thing UGC said. So, according to the Telangana government health report, health bulletin, the corona cases in Telangana is declining and no extra more cases are seen. So there is a possibility of conducting exam for you people in the month of July. Maybe you won't get in June even. In the month of July, they may conduct exam because it is of only 4 days or 5 days. Okay, so we prepare for examinations. In other states, somewhere in Maharashtra, maybe they don't have exams for these yes, first sector. Don't know. I'm guessing it. According to UGC norms, I have seen a slide. I have seen a posting from PTI. Yeah, they said that UGC is saying you can conduct the exams in the states where this corona effect is minimized or less. So Telangana in safe side. Definitely exam will be there. You people prepare for exams. Okay, and submit the assignments. See, even quick assignments also many people are not submitting. Even I'm posting those numbers even in the WhatsApp group. They're seeing it but not submitting. See, accordingly you will get the assignment marks. Okay, you have to submit assignment, then you will get marks. You tell to your friends. Okay, all of you tell to your friends. Right. Okay, today our topic is very simple, interesting. Schrodinger time independent wave equation. Okay, Schrodinger time independent wave equation. We go with a simple steps, a simple phenomena. We take a wave function equation in terms of harmonic function and differentiate that with respect to x position. Okay, then further we take the total energy of the electron. We substitute in this equation. This is the thing we do. A simple one, a simple phenomena, a simple derivation. You today learn it, write it, practice it. Okay. Okay, we'll see now Schrodinger time independent wave equation. So in this equation, we derive without by making time constant. We don't consider the time factor. Another equation is there, Schrodinger time dependent wave equation. There, how wave function is varying with time, d psi by dt also we measure. Okay, let us take a wave equation, spatial wave equation. Equation. Some amplitude a amplitude A and sin kx. Okay, so the wave function psi of x is equal to A sin kx. Let us differentiate this equation with respect to x. So I'm not writing psi of x, it is there. What is the differentiation of sin x? Cos x. Okay, let us differentiate again. Minus, it's a very simple phenomenon, simple mathematics. But A sin kx is what? Psi of x. That will substitute here. Okay. So right. So this is one wave equation. Now let us take the kinetic energy of the electron. What is the kinetic energy of the electron? Particle, fundamental particle. Kinetic energy of the electron or particle is in terms of momentum. Kinetic energy E K is equal to P square by 2m. Okay. So in terms of K, what is the momentum value? Momentum equation. H cut K momentum. Right. So from this, K square is H cut K square by 2m. P square by 2m. P is H cut K according to our de Broglie hypothesis. P equal to H by lambda. H by 2 pi you can write H cut. Lambda by 2 pi, K equal to 2 pi by lambda. Right. So it is H cut K whole square, and from that we have written K square. Let us substitute this K square in the equation 1. Substituting equation 2, that is K square value in 1. D square psi by dx square is equal to minus is there, minus K square. K square is this. Okay. Now let us take total energy of the electron. What is the total energy of the electron or particle? Total energy of the electron E is equal to kinetic energy plus potential energy. So from here, kinetic energy is equal to how much? E minus V. Okay, let us substitute this equation 4 in 3. This is minus 2m by h cut square into E in place of Ek, E minus V we are substituting. Okay, so you can substitute h cut as h where h cut is h by 2 pi. If you substitute that value, again it becomes d square psi of x by dx square plus 8 pi square m 8 pi square m by h square into E minus V psi of x is equal to 0. This is time independent Schrodinger wave equation. Is it clear? It's a simple phenomenon, simple thing, simple mathematics. Take a special wave function for a special wave equation for a wave function psi of x is equal to a sin kx. Differentiate, make double differentiation, then take momentum of or energy, kinetic energy of the electron or particle, right, in terms of k square. So in terms of momentum, substitute here. Take total energy because it possesses both the energies, potential energy and kinetic energy. Substitute. Simple thing, very very easiest derivation. Okay, so this is the Schrodinger time independent wave equation. If you have any doubts, you can ask me in the WhatsApp chat. Now we'll see significance of wave function. Okay, right. So before I'm telling about assignments, there are 8 students. Now number is increased. Tell to your friends. Many are not joining into the class. In other classes also maximum number is very less. Based on internal assessment, based on internal assignments. This time maybe you are going to get credits, but UGC has given directed universities if there is corona effect is very less or it is minimized or it is under control. In those states, you can conduct the examination in the month of July. It is set by UGC. So there is a maximum possibility of conducting examinations in the month of July. Prepare well. You have enough time. You will be at home. You have enough time. Plan accordingly. Okay. You follow that assignment question booklet is there, no, that you follow. Do many programs in PPS. Read it, practice it. Okay. And mathematics, practice many problems, solve it. Drawing, that is also you have to practice well. Okay. So so this is very important thing that's earlier I said it. Now coming to the topic, Schrodinger wave equation. In Schrodinger wave equation, we have taken a wave function and double differentiated it. Kinetic energy is in terms of momentum is taken. The momentum in terms of k. From that k value is taken in terms of kinetic energy. After that, total energy of the particle substituted there. Finally, we got the equation. If you want to write it in 3-dimensional, see d square by dx square we have taken. So in 3 dimension, you can write d square by dx square psi of x plus d square psi of r, you can write r in this is three-dimensional vector notation, plus d square by dy square plus d square by dz square, and psi of r plus 8 pi square m by h square, 8 pi square m by h square into e minus v of r, you can write in three psi of r. That's all. It's a simple. Okay, and whenever you consider in three dimensions, you have to take r, radius vector. Radius vector, it is that represents in space in three dimensions. It will have components x, y, z. Clear? So this is the Schrodinger time independent wave equation. We'll come to one more important point: submit quick assignments. That is very important. Those are objective assignments. Descriptive assignments, already that sheet is there, questions are there, write it, submit to the Balaji sir mail ID. Okay, quick assignments are objective. See, every topic has minimum 5 questions, and one unit has around 8 to 7 to 8 topics. Okay, hardly you are going to answer 40 questions. Actually, in objective test, you have to answer 20 questions, right? So here you are answering 40 questions, and it is not even difficult. I'm providing that YouTube link also. Listen it, then you answer. Listen, answer it. Okay, right. So the previous assignments also maximum 35, 38 students, I think, submitted. Many did not. Based on that only you are going to get marks. Okay. Now, uh, significance of wave function. Psi, basically what it does, psi is a one statistical value, is a complex value. Psi is what it does. What is psi? What psi doing is a particle nature phenomena and associated wave phenomena. Two are there. Particle is moving. Particle is there. Moving particle has wave phenomena. It is associated with wave nature. So this psi connecting these two, the wave phenomena and particle phenomena, with some mathematical or statistical data. It is connecting statistical, right? So it gives statistical information. So mostly what we can say is we can identify the position of the particle, moving particle, in a group of waves. In that way you can think. So it, again, in Heisenberg uncertainty principle, we will discuss it little more. And in your syllabus, significance of wave function, in the sense you have Born approximation. So same, both are same, but Born approximation deals with normalization function. That is the Born approximation. So 3 points are there, you can remember it. One is psi connects particle nature and wave nature statistically. Second one, the significance of wave function. Second one, the Born approximation. What is the thing is, if you take a part, if you want to find out whether particle is present or not in a given region of volume defined in between, so we are taking a small volume, very small volume, which has length dx, breadth dy, height dz. Okay, so that volume we are defining in these limits between along length x and somewhere x plus dx length, dy height, dz width, right? So in that volume, if you want to find out a particle, whether a particle is there or not, if you want to know, if you can write the wave function for that particle, or if you know the wave function of the particle as psi and its complex value psi star, it can be written mathematically. So psi star dx or mod of psi square dx is probability of finding that particle along x-axis in the given dx space. Along dx length, the probability of finding that electron is that. So psi mod psi square or psi star is called probability density, right? Density, whenever you comes to terms density, it is of represents volume. Okay. Psi star dx in the space, two-dimensional space, if you want to find out dy in the volume dz. Okay, where in the volume you have to search for the particle along x-axis, y and z-axis. Okay, closed space. Then in this case, if this value returns, this equation returns a value which is equal to 1, if it returns 1, then the particle is present. It means particle is present. If probability density calculation, if you get 1, that means what? Particle is present. This is called normalization condition. This is only Born approximation. If this equation returns the value 0, then in that given space, in that given volume, there is no particle, right? And one more third point is, one more point is psi is probability amplitude. Psi is known as probability amplitude. So you remember these three points. So if you remember these 3 points, you can write it easily. So Born approximation is only second point, but you write 3 points if it is asked in the examination. First one, psi connects particle and wave nature phenomena of a moving matter statistically. Second one, the probability density. Probability density in the sense, the probability of finding a particle in a given unit volume. Probability density. If that normalization condition value returns value 1, then it is said to be that particle is present in the given volume. If it gives 0, there is no particle, right? So based on that only we have derived next one, particle in a box. We think that particle is present, right? So if particle is not there, what is the use of trying to find it? So we go with that. We assume that particle is there. Here, whatever we are discussing in this case is very simple phenomenon, very simple. But if you go into deep, huge applications are there. Quantum computing, without psi, there is no quantum computing. You people see, many CSC people are entering into that quantum computing. Okay, once quantum computing, already it is in Google also, they are doing it. Once quantum computing comes to the normal usage, then computing speeds increases huge, processor speeds increases in huge manner. This whatever memory slots, that is data storage memory, these things becomes huge. Already we got terabyte, 100,000 like terabytes we got hard disks in a small space, small dimensions. Once quantum computing comes, it increases more. Okay, so this is the topic for today. And one more important thing, you remember, do practice yoga. I'm forwarding the link even. I think today I forward to you just from 7:30 to 8:30. You just follow it, do it. It's very good for physical health and mental health. Clear? And ask your parents to follow it and submit the assignment. Clear? Okay. Almost today we discussed around 30 minutes. Well, I thought to discuss another topic also, but the video becomes lengthy. If it is shorter, you people can see in between and see those videos, answer the quick assignment questions. Right? Good day, all the best, and read very good books. Stay at home and stay safe.